Hey there everyone, this is Jade and welcome back to your second computer graphics tutorial on circle drawing. Now before we delve into the midpoint circle algorithm, I highly recommend that you go back and watch my tutorial on the midpoint line algorithm. I explained a lot of things there and I won't be going into so much details in this one, and the two of them have a lot of common features, so if you understand that one first, it'll only be that much easier for you to understand this one, okay? So yeah, if you've already seen it, then yeah, sure, you can continue with this one. Now, the midpoint circle algorithm is, well, as I told you in the last video, a circle has edge-wave symmetry, so all we have to do is draw this quadrant, octant, and that's about it. That octant will give us the rest of the circle easily. Now, we know the equation of a circle is given by x squared plus y squared minus r squared equals 0, where r is the radius of the circle. If we write the function, we can say f of xy equals x squared plus y squared minus r squared, which is 0 for all the points xy that lie on the circle. Okay? Now just like midpoints line algorithm, once again we choose our current pixel, this one, to be glowed and label it as xpyp. We label this pixel to be E and the one below it to be SE, standing for east and southeast. The midpoint would lie somewhere around here. Okay? Now as you can see, if the midpoint lies inside the circle, then the pixel E is closer to the arc. On the other hand, if the midpoint lies outside the circle, the point SE would be closer to the arc. Okay? So once again, we define our variable D, based on which we'll take the decision as to which pixel we have to choose. Now, the functional equation of D would be given by f of xp plus 1 yp minus half. Because you see, we're doing it with respect to xp yp, and remember from midpoint line algorithm, we say the function would be xp plus 1 yp plus half. Well, back then we went upwards, okay, and we chose between the pixels e and any. In this case, we're actually going downwards, see? That's why we have to minus half from yp in this case. Okay? Now, if we choose the pixel E, say, what will we get? Our midpoint would shift to around here. Our east pixel would shift to here, and our SE would shift to here. Okay? So what would be the new equation for the midpoint? It would be d nu equals to f of xp plus 2 yp minus half. As you can see, it went 2 pixels to the right and about halfway downwards. Okay? With respect to xp, yp. So what's the difference? If we say the difference is del E, because we're choosing pixel E here. So the del E, or the difference between the d nu and do, would be f of xp plus 2 yp minus half minus f of xp plus 1 yp minus half. Okay? Now, I'll solve this equation for you guys to understand. And this will be, we break it down to the circular equation, xp plus 2 whole square plus yp minus half whole square minus r square minus xp plus 1 whole square minus yp minus half whole square plus r square. Substituting the equation for the circle x squared plus y squared minus r squared. So we can see the r square and the negative r square negates each other out. Similarly, the yp minus half whole square and then positive yp minus half whole square negates each other out. So all that remains is xp plus 2 whole square and xp plus 1 whole square, which gives us xp square plus 4xp plus 4 minus xp square minus twice xp minus 2. Solving this gives us twice xp plus 3, which is the del E, or the incremental value for D if we chose E pixel. See? So we have to add this value to the value of D whenever we choose the pixel E. Now, if we selected SC on the other hand, then our D new would be, see where the midpoint was this time. If we chose this pixel, the SE, then our midpoint would be here. This pixel would be E, and this would be SE. So with respect to XP, YP, we would be going about 2 integer differences along the right, and about 3 by 2 downwards, as opposed to the 3 by 2 upwards in the midpoint line algorithm. Okay? So in this case, our D new would be f of xp plus 2 yp minus 3 by 2. Okay? So del SC would be f of xp plus 2 yp minus 3 by 2 minus f of xp plus 1 yp minus half. If you calculate this, we'll find it equals to twice xp minus twice yp plus 5. Alright? So whenever we choose the pixel SE, we upgrade our D by incrementing it by del SE. Okay? Now, the starting D, of course, the D star, is, what would it be? See, this is the point we're starting at, okay? Now, if this point, or the center of the circle, is 0, 0, then our starting point would obviously be 0, r, given r is the radius. Okay? So, our initial midpoint would be f of x0, or in this case, which is simply 0, let me just cut it out, the x part, 0 plus 1, and yp minus half, which is r minus half in this case, because y equals r in our initial state. This gives us 1 square plus r minus half square minus r square. Calculate this, you'll get 5 by 4 minus r. Now, for simplicity and to avoid the fractional term, we can simply say this is equals to 1 minus r, because 5 by 4 is really, really near to 1. We could have just formed another variable to avoid that fractional term, but this way is better since we don't have to do all the extra calculation, and yeah, this is much easier to remember. Anyway, so that's about it. If our D value is greater or equals to 0, we choose the pixel SE, okay? And if D is less than 0, we choose the pixel E. Pretty much the same way as the midpoint line algorithm. Alright, so if we're given the center of a circle and the radius, then we have to calculate the initial D star, which is 1 minus r, given from the radius r. We calculate del E equals twice xp plus 3, and del SE equals twice xp minus twice yp plus 5. And then we simply compare the value of D with 0 and select our pixels accordingly. And notice a slight little difference with the midpoint line algorithm in these two equations. In the midpoint line algorithm, we had our del E to be twice dy and del NE to be 2 into dy minus dx. Now these values, dy and dx, were constant, meaning del E and del NE were constant. In this case, we have the embedded variables xp and yp within our del E and del SE, meaning that these two are variable terms. So, unlike in the midpoint line algorithm, when we're drawing a circle using the midpoint circle algorithm, we have to be really careful when we calculate these two terms and apply them. Otherwise, if we make a mistake, our circle won't be properly drawn. Okay? So, that's about it, guys. That's the way the midpoint circle algorithm works. In the next video, I'll give you a mathematical demonstration as usual. So until then, take care, and I'll see you in the next one. See ya.